Hello, my name is Billy Dennis, and I'm going to be talking to you today about the MSc in Physics and Engineering and Medicine by distance learning, which is based in UCL's Department of Medical Physics and Biomedical Engineering. Physics and Engineering and Medicine, it's a varied and growing specialism exposed to many subjects. We cover physics and engineering and medicine. We're always crossbreeding between them. It's a key qualification for many hospital clinical scientists and engineers. Those that want to become hospital medical physicists require a master's degree, and we form part of that. So our graduates, they engineer how to examine the body and then treat the problems that can arise from them. They'll also focus on engineering how radiotherapy cancer treatments work, and then develop and apply medical imaging methods that can be used in healthcare. And then finally, there's always a wing that's about the design of these diagnostic and treatment-based medical devices. All of these form part of the subject area of physics and engineering and medicine. So what you'll be learning about the range of all these exciting different imaging methods, from the ancient X-rays up to the most modern methods, which include different X-ray methods as well. So we've got X-ray, CT, we've got ultrasound, MRI, and various optical methods as well. You'll be learning about all the range of these and how they can inform how we treat patients. The Department of Medical Physics and Biomedical Engineering at UCL is one of the oldest and longest established medical physics departments in the UK, with a distinguished history from when the first X-ray devices were operated first at the Middlesex Hospital nearby. The history comes also from having the world's first hospital physicist, Sidney Russ, who worked at the Middlesex Hospital, and the first professor of applied physics, applied to medicine, known as Joel, who was the first chair of medical physics in the world at the time. So we're a multidisciplinary department. Our researchers often work in close collaborations with groups from lots of other areas and fields, and we benefit from the close links that we have with hospitals, research centres and industry. And for example, the department has extensive collaborations with the local UCLH Proton Beam Therapy Centre that benefits our students as well as our researchers. Our facilities have a wide range of locations, some of them across London. They're based in the various clinical departments in hospitals, but also throughout the UCL campus, where you'll find a number of different labs that specialise in research in the various optical and medical device methods that are taught here as well. The department's research strengths include a wide range of areas, lots of focus into medical imaging and the various methods that they include. Also various computing methods that can take medical images and then gain new extra information from analysing them. There's a specialist groups in radiation physics who look at advanced X-ray imaging and radiotherapy and various cancer treatments, including proton therapy. And then there's groups that look more on the medical device side, on the electronic side and the robotic side, designing tools that can monitor the body and sensors that can be implanted in the body, and then robots that can be used to provide surgery more accurately than surgeons could do otherwise. The design of all of these systems is another of the department's research strengths. We work with industry all the time as a department. It's really inherent in our work because industry provides us with a problem, and then we take our engineers and physicists to them to hopefully solve it. As a result, we've got a range of research groups that are internal and external here at UCL. So for example, there's the Centre for Medical Image Computing and the RadNet Centre for Cancer Research as well, that's based here at UCL. And then there are collaborations with many other top universities around the world, and also other research institutions that are more independent, like the National Physical Laboratory and the Francis Crick Institute. All of these are trying to crossbreed our engineers into subjects that can make use of their skills. We also inherently have a lot of collaborators in clinical facilities, most of them here based in London, at University College London Hospital, but also at the Royal National Orthopaedic Hospital, Great Ormond Street Hospital, and many others, because they're providing the medical problems that we aim to solve with our engineering expertise. And then finally, industry methods. These are companies which provide the medical equipment that help inform patients' decisions in some way. And those include smaller companies that are spun out of individual pieces of research done here in the department, to the largest of medical device manufacturers like Nikon and Varian, who build the big MRI scanners and cancer treatment equipment that you find in every hospital in the UK. As a department, we've got a wide range of degrees that you can study. This includes PhDs and undergraduate programs with specific specialisms in biomedical engineering and medical physics. But we're talking today about the postgraduate program, the MSc Physics and Engineering in Medicine by distance learning, which falls specifically under the specialism of physics, perhaps, although all of these subjects will crossbreed with each other. So we have engineers who study the program and computing experts who study the program. The idea is that you're learning a combination of all these different skills. The Physics and Engineering in Medicine by Distance Learning MSc has its origins back in 1958, which was the first master's degree in radiation physics, which was founded at the University of London by Sir Joseph Rodblat. So Sir Joseph Rodblat was a nuclear scientist who worked on the Manhattan Project. He was part of the British delegation that went to Los Alamos. He was also the first physicist to object to the use of nuclear weapons on the grounds of humanitarian reasons. And he later won a Nobel Peace Prize for his instrumental work in the campaign for nuclear disarmament and the Pugwash conferences, which led to that legislation being acted. So that's our history. It comes from this man who was finding humanitarian purposes for radiation physics, and one of them was medical uses like our own. So in 2011, the distance learning route of the MSc opened to replicate the campus MSc, but run online for students who are not studying here in London. And it's for students who want to study our world-leading degree, but need some flexibility for location or for available study time. So they might want to study in their evenings, or they're just unable to come to London. We've got students who are full-time and part-time, up to a maximum of 5 years to complete the program. And it's currently the only distance learning MSc in our subject accredited by IPEM, the national body that forms part of the UK Clinical Scientists Route 2 equivalent. So this is a key part of every hospital medical physicist's job in the UK, requires a master's degree. This is one of the components you can take. So this program is structured around a number of compulsory and optional modules. This means that you can choose to personalise your learning based on individual interest and desired specialism. To view the extensive module information for this programme, please visit the prospectus page. So what subjects are covered in our degree? They fall under 3 categories that I've put here. So foundational materials, that is teaching you the basics that you can then apply into the applied part of radiation physics. The specialisms, which are the individual imaging methods, including MRI and biomedical ultrasound, but also X-ray and nuclear medicine, as well as radiotherapy physics and all the aspects that are required to treat cancers there, but also looking at medical devices in clinical practice and various computing methods to keep at the cutting edge of medical development. And then a major part of the degree are the research projects you'll be doing, both an individual project and a group project to design a medical device and bring it to market. So these are all subjects covered in the degree. So distance learning. Our online courses are particularly suitable for you if you need maximum flexibility in your learning pattern. These can be taken from any worldwide location. All you need is an internet connection. They are designed to engage you in a learning experience that is inclusive and stimulating without the need to visit campus and be on site. Distance learners can receive materials for study in the form of lectures and seminars and tutorials, just like on-campus delivery, but they're made available online. Some students may wish to take up the opportunity to attend live lectures or labs, either in person or online. This is encouraged, but not mandatory. The distance learning program was designed and is run by teaching specialists. It's not simply a replication of the on-campus MSc in video form. It actually has a design behind it based on good educational principles that we know succeeds with students. It gives you a clear structure and aims to give you regular feedback on the work that you're doing, and at the same time give you all the support that you need, so you have a personal on-call personal tutor who can help you with any academic matter to do with the course. It's fully asynchronous, which means that you don't have to study in any live sessions with other students if you're not available. You can study when you have the time. Labs for the programme are completed online via modelling and simulations, or you can visit London as an option to take them live in person. There's also the opportunity to study with other groups of students here on campus as part of the Medical Device Enterprise, a group project you'll do. Every single group has at least 1 or 2 distance learning students in it, and we found that it's a very enjoyable part of the course. Student backgrounds and careers. Most commonly we have students from 3 different backgrounds. We might have students who are working full-time as a clinical scientist in training in hospital, and they require an MSc as part of their accreditation so that they can become a fully registered clinical scientist. In which case, the hospital might give them a day off a week as study leave, and they can study the MSc over 2 years. Otherwise, we might have students who are looking to specialise in a new subject area, learn more about medical physics and biomedical engineering. They have less, perhaps, available study time to study each week, and so they're going to take more time to complete the masters, so they might study over 3 or 4 years. And then finally, we end up with a decent number of full-time students who are available full-time to study, but need the flexibility of location. So they're unable to come to London, they'll study full-time instead online on the degree and complete in 1 year. And perhaps there's all kinds of interests they might go into, including research careers and otherwise. So, recommendations for applicants. What are we looking for? An ideal candidate is likeable, honest and proactive, enthusiastic and committed to the subject, and will give us some evidence of their engagement in clinical healthcare settings before. We'd ideally like to see evidence that you have actually acted on your interest and you're not just saying I'm interested in the subject. We're looking for students with a 2-1 or better in an undergraduate science or engineering subject, and ideally we're looking for previous excellence in research work. It's a major output of the department, and as a postgraduate student you're a part of that, so we're looking for good researchers as well. For further information on the entry requirements, fees and application closing dates, you'll need to visit the programme's prospectus page. This is also where you'll find a link to make your application. Finally, being part of the UCL community is inspiring and life-changing in many ways, not just academically. We're located in the heart of London, which was recently ranked as the best student city in the world by QS Best Student Cities Ranking 2025 for the 6th consecutive year. This means that access to UCL's state-of-the-art campus facilities is complemented by proximity to famous museums and galleries, esteemed libraries and professional associations, and first-rate entertainment and nightlife. Distance learners are still very much part of the UCL community. You'll still have access to the same resources that on-campus students do. Join clubs and societies within your capability, and visit campuses and join events and visits specific to your MSc wherever you can. UCL has a wide range of seminars and events available online which are accessible for all regardless of location. As a distance learner, you can also engage with the student support services. UCL has a team of wellbeing, disability and mental health experts on hand if you are struggling. You'll also have access to the UCL Careers Service, UCL societies and clubs, and on graduation you'll join our global alumni community of more than 430,000 former students of UCL, making sure you remain connected with the latest news, events and opportunities. Thank you for watching this video. We look forward to seeing you soon at UCL.